So this is one unique class where I have less kids. Less kids meaning only two of you now. Okay? Other classes we have 8, 10, 12 kids where my attention is distributed among all the kids. But here it's a privileged group where you have more time to bother the teacher, catch hold of the teacher, ask questions, ask for clarification. Okay? So don't you miss that opportunity. Now for Tanishi, quickly I will tell that better this is a class where I don't want you guys to take notes, because everything that I'm doing, me and the board is getting recorded. So you will have a video of the class that you can watch later to revise and make your own notes. Okay. What we do in the class is we pick up concepts, we learn the concepts, we practice some problems, and anything that is not clear, don't hesitate to ask. Okay, there's no bad question. Alright, so Tanishi is caught in the middle of the storm. So we were doing certain things and we will continue with that. But if something is not clear, you will have to ask me, Tanishi. Okay, don't even worry about it. So just to give you a background, we have, and can you guys see the full screen? Tanishi, Vidanshi both? Okay. And don't treat me like a teacher, treat me like a father, a mentor, whatever you are comfortable with, okay? I have two daughters. One is in college now, one is in middle school. So I know how to deal with daughters, okay? So feel comfortable asking questions. Now, in this class we were doing the unit vectors, okay? We learned about some of the basics of vectors and we practiced some problems. Today we are going to do some more problems on vectors before we go to the next unit called matrices or metrics. Okay. So a question to Tanishi. What do you know about vectors? Any idea? Any background?
It's the last one that we've been through, right? So vectors have the bearing. They have I don't know. You have to solve with sine, cosine.
Okay. So Vidanshi will have to be with me for next 5 minutes, okay? This is something that you will hear as a repetition of what you already have gone through. But okay. So, and beware, Tanishi, you will hear some dad jokes. Okay. Alright. So to begin with, what is a vector? Anything that we see around us, mostly numbers, be it a natural number, whole number, fraction, decimals, whatever. If I just put a number 5 here, this is just a number, and you guys can see the board, okay, right? Whatever writing is visible, right? Yeah. So if I'm just writing a number here, whatever be the number, be it fraction, decimal, natural number, whole number, whatever it is, these are also called scalars. It just has value in it. There is no direction. So when you put a number and on the head you put an arrow, I know it's early morning things. So if you need water, coffee, whatever, just manage it, okay? But I'll make sure that I'm making you guys up. So if you have a number with a direction to it, that is when it is called a vector. So now, and we just don't put a number and an arrow on the top of that. There are different quantities that we measure. Let's say I'm measuring distance from, let's say from my house to Vidanshi's house. That will be probably 1,000 miles. Vidanshi is in Chicago, we are in Dallas. Okay, so distance from my house to Vidanshi's house or from Tanishi's house to Vidanshi's house is 1,000 miles. I believe Tanishi is in BMW as well. Yeah? Okay. So from Tanishi's house to Vidanshi's house is, let's say 1,000 miles. So that 1,000 miles, if I just say This is still just something which is a magnitude. It doesn't have direction. I'm not saying for going from Tanish's house to Vidansi's house, am I going to go north? Am I going to go south? Am I going to go eastward or westward? Right? And you can follow me, okay, Tanishi? Is my accent bothering you? No. Okay, good. So here I'm just saying distance. This is a scalar quantity. If I put an arrow on the top of that, now I'm saying for going from Tanishi's house to Vidansi's house, we have to go towards north or northeast. Yeah? So I'm saying 45-degree northeast. Now it makes more sense. Now if Tanishi decides to go and meet Vidansi, she knows which way to go. She knows the distance, she knows the direction. That is why it is called as a vector. In simplest form, the quantities that we measure with only magnitude, those are called scalars. If we measure the quantity with a direction to it, that is called vector. Done deal? So if you talk about distance, that is a scalar quantity. If you are calling it displacement, displacement is a vector term. You cannot say 20 miles without giving direction to it for being called displacement. So there are terms that are vectors and there are terms which are scalars, and there is always a counterpart of that. Let's say if you're talking about speed, I'm driving at 40 miles per hour. Let's say 30 miles per hour in a residential zone. So that is just a speed. If I'm saying I'm driving 30 miles per hour towards north in a residential zone, they are talking about velocity. So you will come across these terms very often, and you would have come across this in physics also. That only a quantity without a direction or a quantity with only magnitude is scalar, quantity with direction is vector. Okay? Now, coming to the next thing. Okay. So now if I'm trying to represent a quantity, a magnitude, let's say I'm talking about representing velocity of, my average driving velocity every day, going from work to office. 60 miles per hour. In northeast direction. So this is a vector. You can represent the vector in a coordinate plane as well. Because you have the magnitude, you are saying, okay, this is the length of the thing that I am measuring, be it velocity, be it distance, whatever, in this direction. So I am representing a vector in a coordinate plane. We can do that always. And here when you see, there are two things that we are noticing. This magnitude, the length of the line segment that I am trying to depict. Okay? And the direction in which it's going, also represented. So the direction you measure always against the x-axis, the positive of x-axis. The time I change this to this direction, my magnitude remains the same, but my direction changed from this angle of 30 degree, let's say, to this angle of maybe 135 degree. Okay? So in a nutshell, what we are saying is, vector is something where you have magnitude as well as direction. So this vector and this vector are different. Even if the length of the line segment are same, they are different. Because vector has two elements to identify it. One is the magnitude and second is the direction. Here and here, even if your length is same, meaning magnitude are same, the directions are different. So they are different vectors. Okay? Now, as you rightly pointed out, Tanisi, that if you have a vector, you can break this into two components in the x and y direction using SOHCAHTOA. So that is what you were talking about. Let's say this was a vector. Let me use an easier, more friendly number. Let's say this was 5 centimeters. This length of the segment was, line segment was 5 centimeters. And this angle was 30 degrees. So you will say, okay, if this length is 5 centimeters, this angle is 30 degrees, how much is this one? So SOHCAHTOA says sine of an angle equal to, let's say this length is along the y-axis, I will put it as delta y, and this is along the x-axis, I will put this as delta x. Okay? So delta y by 5 is sine of 30 degrees, correct? And similarly, if I look at the cosine of 30 degrees, that will be adjacent side by hypotenuse. So delta x by 5. So from this, I am not trying to calculate this right now, but what I am saying is this delta y will be equal to 5 times sine theta, sine 30 degrees, and delta x from this one will be 5 times cosine of 30 degree. Yeah? And I'm not going into finding this out, but this delta x and delta y that you said, that you see here, the x and y component, you literally split this into two parts. Horizontal component or the x component or the y component. These are called elements of these are called components or elements of the vector. So any vector that you have, you can find out the x and y component and they will be called the components or the elements of the vector. So you might be given a vector, let's say I have two vectors here in the class, like I have two kids here. I have vector Vedansi and I have vector Tanishi. Okay? And I can say these are vectors. I put an arrow on the head so that it denotes that's a vector. Vector Vedansi is, let's say, 7, 8. Vector Tanisi is, let's say, 8, 9. You might be given vectors like this. The way you will read it, the first one is my x component and second one is my y component. And you can add vectors, you can subtract vectors, you can find out the flip of the vector. And I'm not going to go into that, otherwise Vedansi will start hating you for this. So Tanishi, what I would suggest is, since we are starting a new unit from next class, for today, whenever I come across these vectors while solving problems, I will touch upon those concepts so that you are able to catch up on that. And I am giving a small task of watching the video of the last class where I did that. Just go through it once. Not that I am trying to avoid spending time, but I am trying to see how effectively I am explaining things when my kids are watching the video. Okay? Just as an assessment, I am just trying to do some introspection for my own work. Okay? And then you will come back to me saying, sir, you explained this to me in the class, I watched the video, it doesn't make any sense. And that's okay. I'm a very brave guy. I'm ready to get candid feedback from my kids. Okay? So I'm just doing something in a more creative way. Okay? Just spend 15 minutes to watch the video. Whenever you find me blabbering, skip that. I do a lot of preaching in the class. Okay? You skip that part and then only look at the meat of the content. Okay? And then you will tell me whether it made sense to you or not. Because I'm trying to do that with a purpose, okay? Because what happens is you guys have a lot of things happening in your school. So sometimes if you're not able to join a class, is the video effectively working for my kids or not? That's what I'm trying to figure out. Okay? That's why giving some work to you guys, and we'll see how effective that is. Okay. So now what I will do is all that time that I borrowed from Vedalsi for bearing with me is over. Now what we'll do is we will pick some problems. Yes, brother.
I had a question. So like, sorry, in our school, the magnitude of the vector is also called the speed or velocity of the vector. Does that mean the slope is the acceleration?
Say it one more time.
But in our school, they told us that magnitude of the vector is sometimes also called the speed or the velocity of the vector. So then should it have acceleration as well?
No. So I will not look at it that way. See, speed and velocity are two vector. So speed is a scalar term, velocity is a vector term. Speed doesn't have direction to it, velocity has direction to it. So as soon as you have a vector, now let's visualize a vector in a coordinate plane. This is one vector, and let's say this is another vector. Be it velocity, be it acceleration, be it whatever. Speed and velocity, those are terms. Okay? Some could be vector, some could be scalar.
No. That's not what I'm saying. It's like when you draw the vectors itself, the companies and everything, another name for the magnitude is called the velocity. That's what they told us.
Not that I would know, because my vector has a long range. I can have a vector which is displacement. That also has magnitude and direction, but can I call it velocity? No.
But they told me that the ultimate name for the magnitude of a vector is the.
Interesting. I mean, again, I'm not a qualified teacher. I have been a student, and that's what I'm passing on to you guys. But would I call the magnitude of vector velocity as an alternate name? I am not sure. I don't think that will be the case, because my vector is a Pandora box which could have multiple things into it. So if I say that magnitude of all vectors can be termed velocity, that doesn't sound like a right statement to me. Okay? Because in physics, right? I mean, when I'm just giving two examples: distance and displacement. Distance is scalar, displacement is vector. You go to speed. Speed is a scalar, velocity is a vector. You go to acceleration, rate of change of speed. That is just acceleration. Speed increase or decrease. But you go to acceleration, rate of change of velocity. That is what is acceleration. Acceleration is actually a vector. But again, I'm trying to recall what all I learned 35 years ago while learning physics, okay? But I'm just giving examples, right? So basically, I'm not convinced that we'll call it velocity. I will check on that, okay? Because if your teacher is right with the reasoning, I should not misguide you. But right now, if I think of it with my understanding of things, I would not agree on its face value. Okay? Alright. So Tanishi, this is one other thing. I am open to debates, okay, and I encourage my kids to do debate, because when you exchange information, that is when we confirm our understanding. It might happen that some of the things that I believe is right might not be right always. That is when you guys will correct me to make me a better teacher, and that was the preaching I was talking about. Okay, so coming back to this one. But Vedalsi, you had some merit in the statement that you made. You said that, will I have a slope? Yes, will I have a slope. Any vector is a line segment. It's making an angle with the x-axis. That has a slope. And a slope, you guys know. What is a slope? Yep. Tanish, you okay with that? Okay, good. Now, what we want to do is, we want to practice some word problems. Because life is not so very easy. They will not tell you, okay, this is a vector, find out the components. They will give you, like I said, in my class of 1 hour, I am doing a lot of preaching, a lot of blabbering. So the meet is only 15 to 20 minutes, where you are actually learning. Likewise, you will have questions, word problems that will be written in 2 paragraphs and the meat is only this much. That is what you have to decode for solving it. So let me read a word problem and we'll try solving it together. I'll first let you guys take a punt at it, and if there's something that is not easy, we will decode it together. Okay, so let me read one of the problems. A metal ball lies on a flat horizontal surface. So now Viransi will have another reason to be concerned. This is the method that we use for solving any energy problem. This is my recommendation. Did you come across this Viransi before?
You told me this.
Okay. So again, I keep reminding you guys because I believe this is the method to the madness. Any problem that we solve, you can use this technique. I'll go quick. If I stitch a story around it, that story is who wins the race depends on who ran the best. Okay. Now what is ran? R stands for read. A stands for analyze. And N stands for Nike. It might be sounding weird to Tanishi. But Nike, what is the slogan of Nike? Just do it. So that's what I'm saying. You have a problem at hand, you have to solve it. Read the question once, twice, thrice till you are convinced about what the question is. Till you are sure that you have extracted all the information from the question. Then you start analyzing it. You start putting your thoughts together. Okay, this is the question, this is the information I have. This is how I'm going to approach it. These are the methods, formulas I will use. You have made your mind. Then you go to Nike. Just do it. So in summary, what I'm saying or preaching is, don't jump onto any problem right away. Read it enough. Be sure about the ask. Then you start putting your thoughts. Then you go solving it. Because maximum mistakes we make while solving problem is, we start solving immediately. If you don't put enough thoughts around it, if you don't read the question well, there's a high likelihood that you'll go in the wrong direction and then you'll realize halfway through that, oh, I chose the wrong path. Okay, so that's why I repeated this, and tomorrow if I have another child in this class, Tanishi will have the same problem like what Vedansi has right now. Had to go through this RAN strategy one more time. But again, it's a reminder that we have to keep practicing something that helps. Okay, coming back to the question. A metal ball lies on a flat horizontal surface. Let's say this is the metal ball. It's attracted by 3 magnets placed around it. So there is a magnet here, there is a magnet here, there is a magnet here. Yeah? I mean, I'm just picking it up. The first magnet's force on the ball is 1 Newton in the eastward direction. Okay, so now we are getting some clues. So all this to be removed. And so first magnet force on the ball is 1 Newton in the eastward direction. So this is where the magnet is. This magnet is pulling it in the eastward direction. Okay, let me read the question, then we'll draw it. Otherwise it will be confusing. The first magnet's force on the ball is 1 Newton in the eastward direction and 2 Newtons in the north direction. So first magnet is, I don't know where it is, 1 Newton in the eastward direction and 2 Newtons in the northward direction. This is the first magnet. Now we are getting some sense of it. This is the first magnet. The second magnet's force on the ball is 1.5 Newton in the westward direction and 1 Newton in the northward direction. So second magnet is 2. So this was 1 Newton, this is 1 and this is 2. This one was 1.5 Newton in the westward direction and 1 Newton in the northward direction. The third magnet, so this magnet is here. The third magnet's force on the ball is 2 Newton in the eastward direction and 2.5, okay, so 2 Newton in the, this is 2 Newton in the eastward direction and 2.5 Newton in the southward direction. What is the direction of the resultant force acting on the ball? So now, so we have to find out the rotation. Okay, let me read the last part of the question. It's saying, what is the direction of the resultant force acting on the ball? Round the answer to the nearest integer. You can intermediate value. You can round intermediate values to the nearest 100. So it's ultimately saying, what is the direction of the resultant force acting on this ball? One last time, I'm reading the question one last time for everybody to digest this, because I strongly believe that all of my RAM means read the question once, twice, thrice till you are clear about the question. So I'm just reading it one last time. By the way, Dansi already heard the question and she's working on it, but that's okay. A metal ball is placed on a flat surface, horizontal surface. It's attracted by 3 magnets placed around it. The first magnet's force on the ball is 1 Newton in the eastward direction and 2 Newton in the northward direction. The second magnet's force on the ball is 1.5 Newton in the westward direction and 1 Newton in the northward direction. The third magnet's force on the ball is 2 Newtons in the eastward direction and 2.5 Newtons in the southward direction. What is the direction of the resultant force acting on the ball? Okay? I will let you guys deal with it for 2 minutes. No, not 2 minutes. Maybe 3-4 minutes. Is that enough? Okay. Can you see okay? Deal with it, struggle with it, and then we will solve it together. Okay. Did I give you a shock? This problem can be solved in 2 minutes. Let's see how you are approaching it. So can I bother you guys now? Tell me what's happening.
So, the data register which direction for each of the pixels in the first course with the 1 and the 2 as the magnitude as the components would be like tangent inverse of 2. The third one with the forces with components 2 and 2.5 would be tangent inverse of 2 over 2.5. The second one would be tangent inverse of 1 over 1.5. But if we were to think about it like in more physics standard, then we would have to calculate the F net, and I assume that it's going to be bigger than
Okay.
it's going to be more often.
Okay. Let's see what Tanishi is thinking. And again, see, I'm trying to poke a hole into everybody's brain to understand in which way we are thinking. I cannot hear you, brother. Your sound is not coming through.
Can you hear me now?
Yeah, I can hear you.
Okay, cool. I said I used Pythagoras theorem to solve them, so I don't know if that's right, but for the first one, I got like the square root of 3.25, and then the second one, I think I saw this one wrong because I just thought it was like 2 over 2, but it's 2.5, so I got to that one, but and then I got 5 for the other one, the square root of 5. So.
Okay. Now I will show you guys a lame method to solve it. Okay. So, and again, don't catch hold of me for using those uninteresting words. So I said I'll show a lame method of solving it. Now, again, Tanishi has not been part of the class, but Vidanshi were there, where I was saying that if I have, so here, when I look at, before I go there, reading the question you guys did enough, write down in the analysis phase. Okay? And when I'm analyzing it, to me, this is a vector. First one is a vector. This magnet is applying two forces. One in the east direction, one in the northward direction. This is second magnet which is applying force in the eastward direction, not southward direction. This is the third magnet applying force in the northward direction and westward direction. So essentially, if I look at it little carefully, these are three vectors. This one has x component, y component. This one also has x component, y component. This vector also has x component, y component. What we are trying to find out is resultant of the three vectors. Now, if you go to this concept, if I have three vectors, I am trying to find, let's say I have two vectors, this vector and this vector. Okay? My resultant vector would be, I will just slide this guy and make sure this guy's tail coincides with the head of the first vector. And this will be my resultant vector. If I have three vectors, let's say I have three vectors, why to do this? And let's say another vector like this. And I have to find out the resultant of this. What I will do is, I will slide this guy to make sure that this guy's tail joins the head of the first vector. Then slide this guy to make sure this guy's tail joins the head of the second vector. And this is my resulting vector. Okay? This is the optics part of it. Now, when you look at the mathematical side of it, let's first do this one. Let's see, I want to represent this as components. This is in the eastward direction. So this is, if this is my x component, this is 1 and positive 1. Yeah, because it's going in the positive x direction. If this is my y component, this is going to positive y direction. So this is the component of the first vector. Will you see it better? If I look at this vector, my x component is going in the positive direction, I am putting it as 2, but my y component is going in the negative direction, which is minus 2.5. I am just putting a sign to it. This is my third vector where y is going in positive direction but x is going in negative direction. So minus 1.5 and 1. Yeah? My y component is 1 Newton in the northward direction. So 1. I'm just not writing Newton right now, but that is implicit. So now I have the components for this vector, x and y components for this vector is minus 1.5 and 1, 1 and 2, and 2 and minus 2.5. So visually we saw that if I have to join or add 3 vectors, this is how we will add them. Connect the head and tail together. And we can choose something of our preference. If you want to add this guy first, you will say, okay, fine, I will add this guy first. And then join the third one. You will land in the same place, okay? I did not do a great drawing, but I am saying, you can choose how you want to add them, okay? So this is the visual part. I am saying that from this component, what we did was we had a magnitude, we just added the sign to it so that it becomes more, the direction is also clear. Now when you are adding vectors mathematically, you don't have to do any magic. What you will do is resulting vector. Let's say this is the resulting vector. What am I writing? Let's say vector which is a result. The final force getting applied on the ball. What I will do is, I will do a lame thing. All the x components will be added together. 1 plus minus 1.5 plus 2. So 1 plus 2, 3 minus 1.5. This is 1.5. I will add all the y components together. So 1 plus 2 is 3 minus 2.5, which is minus 0.5. This is my resulting vector. And so here what you are seeing is your x result. X component is 1.5 and y component is minus 0.5. So if you want to visualize this in the coordinate plane, this resulting vector x component is 1.5, let's say this much, and y is minus 0.5. So it's going in this direction. So basically x is going in this direction, y is going in this direction. So your resulting vector will be something like this. If you look at this picture, I know Vidansi is still trying to think and digest. So is Tanishi. And that's okay. So what I'm trying to say here is, if you have multiple vectors working on something and you're trying to find out the resultant vector, you don't have to stress too much about it. You have to see if you have the x and y components, and if you find out the resulting vector, you will just add them together. All the x components together, all the y components together. That will give you the resulting vector. Okay? And if you want to relate that visually, also, you can see we had three vectors. First one was x positive, y positive. So something like this, in this direction. Second vector was this way. And third vector was going this way. So what you are doing is you are combining them. And then you are going this way. So this is a resulting vector. So here I did not do a great job with respect to this drawing this picture, but in simplest form you have to relate to it that resultant of two vectors or three vectors can be done mathematically by just adding the x components and adding the y components together, that becomes a resulting vector, and from that you can find out the angle. How will you find out the angle? So come down. Yeah? Make sense? Or I am still blabbering like always? No? Okay. So this is something. While whatever Tanishi tried, whatever Vidanshi tried, there was a lot of merit in that. I'm not denying that. But what I'm saying is, these vectors can be solved in an easier way. Don't overthink. Don't stress out too much. It's like connecting the head and the tail. You have two vectors to add them. Find out. You can choose which vector you want to add with whom, which tail you are connecting with which one. Now, just to help you guys recall, and Tanisha, when you watch the video, then you'll probably be able to relate. Now, let's look at some of the basic rules. If I have, let's say, vector, any vector, it doesn't really matter from where I'm starting. What matters is the magnitude and the direction. So my vector coming here, this vector are same, as long as the lengths are same, and see the directions are matching. So vectors never restrict us to define the starting point. It only cares about the direction and the magnitude, that's it. So you can have the same vector here also, as long as the direction, meaning the angle with the pointing axis is matching. This is one. Second rule of thumb is, or second interpretation from this is, that you have a vector A and you have vector B. If you want to find out vector A plus B, you will just slide this guy here. This is from here to here, this is a resulting vector. If you had a vector A, this is a vector B, and you want to find out A minus B, this is A and this is B. You want to find out A minus B, meaning you are doing A minus B same as A plus minus of B. What is minus B? You will just flip this guy. That is minus B. You look at the same magnitude with a rotation of 180 degree. That is your minus B. If you have to find out minus A, that you are just flipping it by 180 degree. If you relate that with your understanding of SOHCAHTOA, your basic geometry, you will see that the slope here and the slope here are just opposite. This is a positive slope, this is a negative slope. That's why this is minus. So now the next thing is, we saw how do we do A and B, A plus B. Oops. So if you have to ever find out the resulting vector, you can connect the head and tail. You will just slide it in a parallel direction. You are changing direction. You are just shifting it a little bit and connecting the tail and the head. And then join the two ends. That is your resulting vector. Mathematically also, if you have vector 1 with components as 3, 4. Okay. Now you will think that, okay, but just by having numbers, how do I know the direction? Simple thing is, this is x is positive 3, meaning x is increasing, and y is also positive, meaning y is also increasing. So you are looking at a vector like this. So just by number you can figure out the direction. Even if it might sound like no, there is no direction here, but there is a direction, because the sign matters. Vector v1 and vector v2 are not same. This guy has a different direction. So if you have two vectors and you have to find out the resultant of that. What you will do is, if you have to find out V1 plus V2, you will add the x component together, you will add the y components together. They are, for lack of a better word, they are enemies. X and y don't talk to each other. You are only adding the x together, only adding y together. Okay? So if you have to add 10 vectors tomorrow, you will not overthink. You will just put all the vectors, x and y components, add the x's together, add the y's together. Yep. So that is all I have for today. This was one sample example that we just looked at to solve in a simple, easy way. So two things I want to do. I'm not going to talk about vector at least for next couple of months. That's my plan. Unless Tanishi wants me to change the plan. What I mean by that is, I would want Tanishi to go through the video of last couple of classes. Let me send you the link of those videos right away. And I have sent you a message, okay, to join the WhatsApp group so that you will have all the information and everything.
I'll make sure to do that, yeah.
Yeah. So, I will send you the video of last couple of classes, which I would want you to watch, and then come back to me saying, does it make it clear or not clear? And that will give me guidance with respect to whether we are going to talk about vector in the coming class immediately or not. However, if you have any doubts, we can simply talk about it. I mean, it will not be full blown one class for clarifying doubts. Right? Then we'll accommodate that. Next class we'll go to metrics. That's why it's an interesting movie which I never bothered to watch, but we'll talk about matrices. Okay? So now the task that I have for you guys is, I would want Vedansi to solve the other problems that I have posted in the group, okay? In the same WhatsApp group. Try solving those, applying whatever you know. It's like 4 or 5 problems. See if you are comfortably able to solve them or not. If there's something that is bothering you guys, obviously ask me in the next class. For Tanishi, the task is go to the video of the class just to make sure that you are able to package your understanding as a bundle and then apply that for solving those problems that I have put in the group. And if something is not clear, then you know who to catch your life. Have fun. Have fun. Yeah.
Is it the WhatsApp group?
Yes, madam.